Hello everyone, this is Dr. Praveen from ADARSH MANDIR, Mountain. Students, today we will learn how can we draw MO energy level diagram of some diatomic molecules like B2, C2N and 2 and O22 and N2. So actually these are two general diagrams I have drawn here. We can use this diagram, the general diagram for these whole molecules B22 and 2, and this diagram is for O22 and N2. Now if you just see what is the difference, if you see the first diagram that is used for the B22 and 2 molecule. So you know when we feel the electron in an atom, so we start from 1s. After 1s we feel the electron 2s and then 2p. So you see these are the atomic orbital 1s, 2s and 2p for one atom. And in opposite side, as they are homodiatomic molecule, so same metal will be there, and we have got same atomic orbital 1s, 2s and 2p. Now 1s combined with 1s to form what? Two MOs, sigma 1s bonding and sigma 1s start anti-bonding. 2s combined with 2s to form sigma 2s bonding and sigma 2s start anti-bonding. And in similar way, 2p combined with 2p. So in P there are three orbitals, px, py and pz. So when px overlap, sigma bond is formed. But when pz and py overlap, so there is formation of pi bond. So according to that, which type of bond is formed, we give the name of what? Molecular orbital. If sigma bond is formed, then the name of or symbol we use for the molecule is sigma. And what type of orbital are combining? So we write down after that. So here you can see 1s combined with 1s, so we have written here sigma 1s. Okay. And same way 2s combined with 2s, so sigma 2s. So here 2p combined with 2p. But actually in P subshell we have 3 orbitals. So actually 3 orbitals are combining with 3. It means overall 6 orbitals. So according to rule there will be 3 bonding and 3 anti-bonding. So we know the energy of bonding is less than anti-bonding. So we have here these 3 orbital here and 3 that one. But we have also 2 groups here. I have written here that just see the name pi 2px and pi 2py. And then sigma 2pz. These are the bonding MOs. And after that pi 2px anti-bonding, pi 2py anti-bonding and sigma 2pz anti-bonding. These are the anti-bonding molecular orbital. So you can understand this one. That it means when there is a combination of the p orbitals, so 2 types of bonds are formed. There is overlapping of the p orbital, sigma bond and 2 pi bond. If you just see, you can see. Suppose we have this p orbital, so we have 3 types of p orbital: px, pz and py. So when there is overlapping, you can understand I think. So that is the action overlapping. So that is sigma bond is formed, 1 sigma bond is formed, and you can see that 2 pi bonds are formed. Okay. So actually we have 2 groups here, sigma orbital and pi orbital. Sigma MOs you can say or pi MOs. Okay. And the energy of the pi orbital is equal. So they are at same level. Pi 2px is equal to what? Pi 2py. They are at same energy level. But the energy of the sigma 2pz is what? More than that, this pi. Okay. So that is the way to represent the molecular orbital. Now we have to suppose fill the electronic configuration, or suppose we want to draw the MO energy level diagram for B2 molecule. So it's very simple. At the place of atom we will write the symbol of the atom. Suppose we want to draw B2, MO is the diagram of B2. So you know what is the boron? Atomic number is 5. So that is 1s2, 2s2 and 2p1. So first we have to fill this electron in atomic orbital. Okay, so we have 5 electrons, so we can fill, that is what? 1s2, 2s2 and 2p1. We have filled this electron, and similarly we also fill the electron here, 1s2, 2s2, 2p1. Okay, so overall we have what? 10 electrons. So we have to fill 10 electrons in MOs. So we start from here, from lower energy level. Okay, we start from lower energy level. So these 2 electrons and 2, then 2. So these are the 8 electrons. Now we have to fill more 2 electrons. So we have to fill these 2 electrons according to Hund's rule. So there will be 200 electrons. in pi to px and pi to py. Okay. Here Z is actually molecular axis. Okay. Z is assumed to be molecular axis, so that is sigma to pz. So we have filled this 10 electrons in MO. So that is the MO energy level. But we also see that also I have the symbol for boron P2. You can write B, B, and B. Okay. So we have used the general diagram and we have made the MO energy diagram for B2 molecule. That is the way you can draw. Now you can calculate the bond order also. Now the formula we use, you know, R, number of bonding electron. Now we count the bonding electron. So if you see this 2 electron and then this 2 electron, 4, 5 and 6. There are 6 bonding electrons. Now what is the number of bonding and antibonding electrons? So there are, you can see 2 in antibonding, 2 here also in antibonding. So 4. So that is what? 6 minus 4, that is 2, 2 by 2, that is 1. So the bond order for B2 molecule is 1. Okay, and it is paramagnetic. Why? Because there are 2 unpaired electrons. So that is the diagram. Okay, you can take the screenshot or draw this diagram. Now next we have to draw for carbon C2 molecule. For C2, the carbon you know, the atomic number is 6, so you can write a coefficient that is 1s2, 2s2 and 2p2. Okay, so now we have to fill, that is the C2 molecule. Okay, we are going now. So we have to change the number of electron actually and symbol also. So for C2, C and C2, and the configuration that is 2p2, 2p2. Now we have to fill 12 electrons. So now we have increased 2 more electrons in MOs. Now you see that is the MO energy diagram of C2 molecule. Okay. Now you can find out the bond order. That is bond order is equal to R number of bonding electron. That is what you can count as number of bonding electron. So 4, 5, 6, 7, 8 electrons. And antibonding there are 4 electrons. So that is what 4 by 2. That is 2. So 2 is bond order for C2 molecule. And you can write the electron configuration also. Okay. How? You can just fill the electron sigma 1s2, sigma 1s star 2. Okay, then sigma 2s2, sigma 2s star 2, pi 2px2 and pi 2py2. That will be the electronic configuration of C2 molecule. And in similar way you can write the electron configuration of B2 molecule also. Okay. Now next N2. So in N only we have one more correction there. We have to change the symbol. N2 it will be N and N2. Okay. And the number is 7, so you can write what is the number of electrons in N? 1 and 2, 2s2, 2p3. Okay, according to atom number 7. So we just correct that 2p3. So now we have to fill what? 14 electrons. So you can fill 2 more electrons in MOs. That is MO level diagram of N2 molecule. You can find out the bond number. That is half number of bonding electrons. You can count number of bonding electrons. 8, 9, 10, 12, 13, 14. There are 14 bonding electrons. Okay. Count, just see. 2 here, that is bonding. 2 here, that is bonding. That is 4. Then 10 electrons are there. Okay. And antibonding, just count the electron. So there are 4 there are 4 antibonding. Okay. This one and this one. So that is what? 10 minus 4, that is 6. So 6 by 2, that is 3. So that is the bond order for 3 bond order of N2 molecule. You can count. Okay. Now that is the diagram you can use for O2 and E2. So in this, what I changed, just see, the energy of sigma 2pz is less than what? Is less than pi 2ps and pi 2p value to sp interaction. And further you can fill the electron for O2 and other molecules. Okay, thank you.